right, so my name is Mohammed. I'm from Seagate Technology. A good introduction would be if you go to Seagate.com and download any tools that work with any of the Seagate products. I probably have some fingerprints on it. That's pretty much the best way to kind of describe what I do at Seagate. So mostly on the host software side. When I was actually trying to present this, I was thinking about just calling it an introduction to openSeaChest. But then the speakers said that, oh, create a very interesting or somewhat controversial, So I came up with this, but in hindsight, like I was saying, I should have actually said what's better than NVMe CLI, and then I would have been a much better crowd. So one of the things that I will talk about in this talk is not going to be any of the IOPS, performance, bandwidth, things like that you guys want to been hearing about. It's mostly about portability. I think that's probably the key that I would like you guys to take away from. So the problem statement usually comes around as, sure, we can do all these things, but we have a bunch of drives in our racks, which some of them are with Seagate, some of them are non, and we have different vendors. And when you're supporting the entire, so we have customers that are as low as set-top boxes, which are running their own embedded Linux and things like that in a very small, chassis or whatever, all the way to people like IBM or Amazon or whatever, right? I mean, on the other side of the spectrum. So, as a tools group or the group that works on software, host software, you have to support everybody and in the middle. So the things is that you have to support multiple operating systems. You can't just say, oh, I have only tools for Windows or I have only tools for Linux. You have to go beyond that. Architectural portability is, we have people that have requested MIPS and tools that runs on MIPS. We have people who have requested, believe it or not, Windows and on ARM. So we have actually released tools which are running Windows on ARM. Believe it or not, yes, I can actually prove that. So and then they're interface agnostic as well. So we have drives that are SAS, SATA, NVMe, and people are trying to do things to all of them, right? They're not just trying to do one versus the other. And if you give them tools which only do one thing or the other, then they get a little bit irritated. And storage media independent, which has been recent, HDD versus solid state. So you want to be independent to all of them. Self-contained and short dependency tree. So that comes into play a lot, and that's where the dependency comes along, right? So if you have if you do an LDD, on those who are familiar with Linux, on your tool, and you see a big bunch of tree of dependencies, most likely your tool is not going to be portable. Because when somebody's going to say, I'm running my own tool chain and this and that, it's not going to work. Just simple as that. I mean, you just can try to compile it, and they'll have their own GCC, and they have done different things to it, and it just doesn't work. And then last of all, people wanted open source. And this has come up over and over again, and it took me about 5 years to convince my management that it's okay to open source. There's no IP in it. It's all standard. We can make it such that you can keep the IP out and still have everything open source.
What license is it?
It's MPL. So we actually fought for MPL. They were trying to do all kinds of weird licensing, but we said we have to do, either you go GPL, and if you can't do BSD, then let's compromise on MPL in the middle, right? So that's, we talked to our legal team, and we got them all. So another thing which we get all the time is just one tool to rule them all, which is our customers are always looking for, just give me one tool that does everything. Why are you telling me you have to do this for that tool, and you need to go download this for that tool or whatever? Just put it under one thing. So that's the problem statement. So another way to kind of look at, when I was thinking about the vision for the open source project that I have, it needs to be highly portable, secure, because we are going into cloud systems and enterprise systems, and they're like always very worried about security. So they do a whole security audit on your source. So if it is open source, you can actually look at it in that secure. And then non-disruptive, which is if you have 240 drives in your rack and you are just trying to change power settings to 2 of them, if your tool is such that it's going to scan the whole system and put everybody up on the power mode, and then just go change the power mode of two drives, then it's disruptive, right? So you want to be least disruptive as possible. And it can have different use cases, but it's also diverse hardware platform and operating system. So we have seen all kinds of combinations, right? So we're trying to figure out, it's not as much about, our tools are not trying to go do performance testing or things like that. They're trying to just tinker with the drive in a very diverse ecosystem. And you have to make it work in their ecosystem because a lot of times customers have already integrated those drives. It doesn't matter if it's ours or somebody else's. And they can't just say, oh, you need to pull the drive out, put it in this other system, run our tool, and somehow then things will happen. You have to work it in their little system, right? So it has to work like that. So what I'm proposing today is that there's a project that we created, openSeaChest. It's all open source. You can actually download it today, build it. I'm hoping to actually, if you have time, demo it later on. And it's MPL based, written in C. And that was another requirement, which when we started it, we said we'll just use C++. And a lot of people who work at that level, which is at the tinkering level, they're from firmware engineers or hardware engineers, and they just like C. We keep telling them, and they're like, no, we want C. And we're like, okay, we'll do it in C. And it's a collection of utilities written on top of open source libraries. So that's very important. So openSeaChest is just a collection of utilities. But then it's written on top of libraries that you can customize as your use case needs to be, right? For storage products based on storage industry standards, so we're not Seagate specific. You would not see anything which, as far as the code is concerned, like Seagate specific. We have some additional stuff which is Seagate specific, but not necessarily in the command set. The command set is very open, T10, T13, and NVMe. And allows device diagnostics and management or whatever else you want to do. As long as you have a SCSI, ATA, or NVMe command for it, you can actually do it. So the key features are, one of the differences is that if you guys have used hdparm, it's one tool, but it does a lot of things, right? Another comparison would be SmartMon tool, right? It does smart, but it doesn't do anything else, right? So it's a use case based. So what we have done is that we have created a tool set which has a bunch of different tools which are based on use case. So you don't care when you're working with power, if you're working with SCSI, if you're working with an ATA, or you're working with an NVMe, you just want to change the power mode, right? And a lot of it, like for example, the EPC settings, I don't know if you guys are familiar with it, there is the EPC setting feature set, which is both in SCSI and in ATA. So as a tool, you don't care, you just want to, or as a user, you don't care. You just say, hey, I have a bunch of drives, I want to set the EPC settings to this, and you go ahead and do that. So ours are siloed in user, use case. So your erase is a very interesting use case, which I'll talk about later. A lot of our channel customers, which are not big enterprises or whatever, are trying to repurpose the drives. And they have drives from a ton of different people. Drives that they bought 5 years ago, 3 years ago, 2 years ago with different features. And they're repurposing it. Repurposing means just go erase it. So that's a use case, which is very different from Smart, which is very different from if you're trying to download firmware. So our utilities are based on those use cases. It supports all of them, all of the different direct attached protocols. I have a star with NVMe because we're constantly adding NVMe support since we actually do Windows as well, unlike NVMe CLI. And Windows doesn't support a lot of NVMe pass-through stuff, so there's always a struggle. Another interesting thing is that we actually do support VMware, and there's a star on it because it's beta. You're welcome to go right now, download it. If you are a VMware person, go build it, and it actually works. I've actually given it to customers, and they're using it. So just imagine like a code that supports Windows, Linux, FreeBSD, Solaris, and VMware at the same time. And it does SCSI, ATA, NVMe does under VMware, Windows, and Linux. I don't know if FreeBSD or Solaris supports NVMe yet, but yeah. So I mean, at the OS level, it probably does. We haven't ported it in yet. So interestingly, ARM for both Linux and Windows. And then for our other architectures, mostly for Linux, if somebody comes up with a use case of, I'm running MIPS on FreeBSD, we can probably make it work. It's not, we have a very small dependency tree, right? And it's lightweight and portable. It works anywhere. So just to give you an example, I work with an East Asian TV producer, TV manufacturer, and they were putting our drives in their TV. And they have their own tool chain and everything, and they wanted to firmware download and pull some logs and do some other things, I don't remember. And they were looking for tools, and we said, okay, let's try our tool, and it worked. And they were very happy with it, and I'm pretty sure if you buy those TVs, somewhere, if you can hack into it, our tool is binary in there, right? So built on customizable open source libraries, which is basically, I'll later on describe how the whole ecosystem works and it will become clear. And one of the other things that even Seagate people that use these libraries don't know is that it works on all vendors. So a lot of times they don't tell that to customers, and the customers come back to me and ask a question, and I'm like, well, just use this. And they're like, no, this is just only for Seagate. And I said, no, it says open right there. So it works on all vendors. It doesn't matter. It's, as long as it's standard command, it will work. If there is a vendor which has a vendor unique command, we can't really do anything about it, right? So what's the big picture? We have a disk, and I'm slashing it because it can be a SSD, it can be a hard drive. It doesn't matter how it's connected, but there is some sort of a transport to it, right? So we have IDE, we have USB, we have SCSI over, SCSI translation layer, SAT, where ATA is attached to an SASE HBA. We have SAS, we have NVMe, right? So these are all the direct attached, transports, and then we have the three command layers, right? The SCSI command, the ATA command, and the NVMe command. So what we have created is a OpenSea transport layer which encapsulates all of that. So you don't have to worry about, am I talking to an ATA drive? Am I talking to a SCSI drive? Or am I under Linux or Windows? So when you're building a library, so this is a library, OpenSea transport. And when you're building across this library, you don't have to worry about the nuances of Linux or Windows or any of the others. Or even, in most cases, the nuances of the command layer. You just basically just say, hey, go send this ATA command, and I don't care how you're attached, right? So on top of it, we have OpenSea operations. There's another library which tied into with the common library, which is just a differentiation of there are certain things which are common between the two, and we have put it there, mainly because a lot of times when you're doing this level of coding, you're talking about, is this bit set or not? Is this, can you, switch the big Indian versus the little Indian? So those type of stuff is in the common. But the operations is a little bit more than the transport. So transport has everything that a SCSI, if you open a SCSI spec, if you open an ATA spec, and then you look at our OpenSea transport library, you can pretty much match the two together. You can say, oh, you're trying to do a, getlog extended command, and here is an OpenSea transport function which does getlog extended command. But the operation is a little bit more. So let's talk about logs. So when you're actually trying to do an ATA log, what do? You first go check if it is in the GPL log directory. That tells you if the log exists or not, right? Then you have to go find out what size it is, and then you have to go pull the log. So these are three commands you have to actually go do in order to actually do a log pulling from an ATA drive. So that would be an operation. Similarly, if you're trying to do erase, which I'm going to give you an example of later, you don't just go do erase. You actually go first query the drive. OK, do you support this level of erase? OK, you do support it. These capabilities bits are set. OK, now let me go issue this command and then go pull to figure out when the erase is done. So that will be considered an operation. So the transport layer is one command. An operation is a use case based on a collection of commands. So that's our basically the big library structure. And on top of that, we have actually created an openSeaChest utility layer, right? So it doesn't matter what, if you don't like the way we have done the utilities, you can actually use the libraries on your own. You don't have to use our utilities. You can just take the libraries and build your own thing on top of it. So this is basically the transport layer described a little bit more. There's a SAS drive, a USB, a SATA connected, and I have demos where we have all three of them are connected at the same time. And you have an operating system layer and a command layer. So something like the next slide would talk about. So you have a common command layer. So you're trying to do, again, going back to get logs, right? So then you say, OK, I'm trying to get logs. Which of the commands that I need to talk to? And they've already talked about, at that point, it already knows I'm talking to a SCSI drive or an ATA drive or an NVMe drive. So it will go to the respective command layer. And then it will say, OK, now I have the command set up. Now I need to figure out which OS I'm talking to. So then it will say, OK, let me just go send IO. And send IO figures it out. Oh, I'm actually running in Linux. And I need to go send an iocto. Oh, I'm running in Windows. I need to do dev IO control. I'm running in FreeBSD. I need to do cam IO. I'm running in, this is CSMI IO. I don't know if you guys know, CSMI is a Windows Intel driver unique way of doing IO. And then I think in Solaris, it's SCSI IO that you do. So basically, that's how the command trickles down, right? And a good example would be you're doing firmware download. So that's one of the key things our customers do all the time. It's updating firmware, right? So from an openSeaChest firmware utility layer, all you care about is that I have a load file, and it needs to go to this device. I don't care how you do it. That's what the operation that needs to happen. So you just call the operations layer and say, go firmware download. Here's a buffer pointer. Here's a device handle. I don't care how you're running it. Just go do it. So then it goes down in the command layer and figures out, OK, I need to send an ATA command because apparently I'm sending an ATA drive. And then it goes into the OS layer and it figures out, oh, I'm running on Windows, so I need to kind of convert this ATA command into Windows device IO control. And it further goes down. So the same would be true for if we were doing SCSI. The ATA command would be actually a SCSI command, which is write buffer command. And then it will go down. And if we were not running on Windows, we were running on Linux, we will just send a IO control. So that's how it all works. So again, going back to this is the main libraries that work, that basically are the building blocks. And on top of that, you can actually build any type of stuff, right? I mean, so we have 3 different groups within Seagate that are working with our libraries and using Python. We have built our own GUIs using Qt. There was one guy who actually loved C# because that's where his thing was. And I said, good luck marshaling all the, the unmanaged and managed stuff and go hack at it. And there are people who use Java and Go. And so it doesn't matter. So it's just a C library, and it encapsulates all of those things for you. So you can just build on top of it as you like. And if you don't like the operations or the way we are doing operations, you can actually directly all you need is a common OpenSea transport and then your own thing. So a lot of the Python people, especially in our labs, which have very unique use cases, they don't like to use our operations. They said yours is very customer friendly. You're trying to check a lot of things. We want to just hack at it because we know exactly what we're doing. So they don't need the operations layer. All they need is the transport and the common and their Python code, and they hack at it. All right, so it's all on github.com/Seagate. Let's see if there's a pointer. Yeah. So this is the actual openSeaChest project. It has 3 submodules, which are also part of this same GitHub/Seagate, where you can see OpenSea Common, OpenSea Transport, OpenSea Operations, and then openSeaChest. So this includes the other 3 submodules, right? And as you can see, we have a lot of activity. So this screenshot was taken a few hours ago. So this is pretty much what you see in all of them. So we have been developing it throughout, and this is what every time somebody asks me for a tool, if I can make it work here, I would much rather make it work here than any of our custom tools that we have, right? Just because it goes to the community and it's good for everyone, right? And we started in November 2017 when we actually open sourced it. We have been working on it for quite some time. So all of that, I think it's right here, it says 162 commits. So since November, in 10 months, we have that many commits, and that's only on this project. It doesn't include the commits on the transport, which has a lot more traffic, and it doesn't include the operations, which also has a lot of traffic. So it's a very active project, and we're really vested into it, and we're trying to, make the best out of it. So these are the different utilities that you will find. So this is, again, these are utilities, not necessarily the underlying libraries. So you can do a lot more with the libraries. These are just the use cases that we could figure out. So for example, the basics has some of the very basic stuff that any user, if they're like, give me just one, I just want to use one binary which has most of the stuff, that's probably what they will use, right? But then, so this one has a lot of stuff that people like. So for example, provisioning. There's a 5-speed. I just got an email like 5 minutes ago that somebody's trying to do a 5-speed change on a SAS drive and it's not working. So download code is another one people do a lot. So these are just, over the years, people have just, whatever they want something which is very generic, they just argue to put it in basics. And then configure is most of the stuff that you would use to actually configure a drive. And some of them are these utilities are very much overlapping. I don't want to bore you with all the details, but erase is another good one. And I'm going to go over it a little bit more in the next few minutes. But it does all of the stuff that you would do if you were trying to do something with the drive to erase it or repurpose it or, zap it, in other words, right? So let's talk about erase. So there's one, if I go back right here, it says show erase support. And then there's another one called perform quickest erase. So the use case is you're a channel customer. You buy drives from all over. You have racks that you have given to a customer, and now you want to give it to another person, right? So you had one customer that you have built the racks for, and now your contract with them has ended, and now you want to repurpose the drives to give it to somebody else, right? And you have a mix of things, right? So you put some drives in which were a few years older, some drives in which are a few years younger. So what you want to do is you want to find out what the erase support is, how long it's going to take, and can I actually just do in one command the whole thing? And it will be interesting even if they had all of the Seagate drives, depending on which version of the drives and which version of the firmware, the erase support on it will be different. So we created this thing called show erase support. And what it does is that it tells you exactly, which of the erase methods are actually supported. And not only that, it tells you how long it's going to take. So this one is a 10 terabyte drive, a SCSI SAS 10 terabyte drive. And if it says the quickest way to do it is this sanitize overwrite erase, and it's going to take 15 hours. By the way, this is not, if you had ICE supported, which is instant secure erase, it would be done in a minute, and I can do a demo on it as well. Please.
Is there less human-friendly, more machine-friendly options available?
Right, so we talked about doing that in a JSON format. Currently, they're just actually grepping on a lot of text, but there is a big talk. We have some JSON support in the other tools, and they're competing with this tool, so that's why. But in one of my slides, I talk about that what's coming down the pipe, and JSON would be one of them. Right, so another one which I can't demo right now, but basically it's called perform quickest erase. So if you have drives which are from different vendors and they support different feature set, you can actually don't have to worry about it. It can be SCSI and some of the customers have both SCSI and ATA drives at the same time. And you can just call with the device handle, say perform quickest erase, and we will figure it out which is the quickest one which is available, and then just go do it. So you don't have to worry about I have to write this script and all of that good stuff. So that would do it. So a lot of these type of things are just part of our utilities that get you to do it. And these are also, to perform quickest erase is an API from the operations. So if you don't want to use the utilities and you want to create your own ecosystem, you can actually use our OpenSea operations utility and do similar things. This is another quick, so poor man's bus trace. I don't know if you guys do a lot of tinkering, but a common question, just like I did a few hours ago, he's like, well, I tried to do a PHY speed reduction from 12 gig to 6 gig, and it's not working. And I said, well, no, I tested it on my machine, and it is working. So how do you actually decipher who's right and who's wrong? So what we have, and this is a server that is running back in my lab. So let's take so you can actually do a scan and it will give you what is out there. This is kind of like LS-SCSI. And believe it or not, I'll tell my customers, just do LS-SCSI, and they'll be like, no, give us an actual scan from your utility. And I'm like, okay, fine, I'll do it.
Can you make that larger?
Can I? Let's see. Change settings maybe, and then Windows and appearance. Okay.
Yep, you change on the right.
Right here?
Yep.
And what do you guys like? 14?
Try it.
That's 14. Better? A little bit better? Okay.
Chop it off.
All right, so let me actually figure out how to not chop it off. Should have had my mouse here somewhere. Better, okay. So you can do a scan, and it will show you all the drives that are out there. So another demo would be kind of nice. So -I, which is also called device info in the long help, maybe I should talk about this first. So if you do any of our utilities, you just press, just like any other Linux utility, you just press enter and it will show you what all the different things are that it can support, right? And so device info is one of them, and which is a -i. So let's talk to device number SG7, which is a SCSI drive. And it will tell you all the nice things about this SCSI drive, right? So that's just the device info. And by the way, you were talking about doing how we can do machine. So some of the Python people have done it where they key off of those colons and have done a pretty good job. And I've seen their thing work, and I'm like, great, that's even better. So it tells you a lot of information. So the same would be, no change in the command line, and let's like talk to an ATA drive, and that's how the ATA drive would look like. So it would tell you about the model number, the serial number, and it tells you about the firmware revision and all the nice little things. And this is all open source, by the way. Nothing is something unique that we're trying to do. So you can go look at the code and make it work for yourself if you want. So what happens if I'm trying to do this and somebody runs this command and he says, well, I ran this command and the HBA hosed up. I don't know what's going on. So I'm like, okay, well, let's try to figure it out. So what commands am I sending to actually create all of this big tree, right? So I say verbose, and a lot of utilities actually do that. But I'll show you what we think is pretty cool about it. So when you do a verbose, it tells you exactly which command it's actually sending down, and what is the return mode sense or whatever thing is coming back, right? So this is all interesting, but what happens when I do a 3, and then let's do more. So now it's actually telling me which of the commands I'm sending. So I'm sending SCSI inquiry command BPD89, which actually tells me if it's an ATA drive attached to a SAS HBA. This is the CDB I sent. This is the sense code I got back. This is the sense key I get back, and everything. So each of the commands going down, it will tell me which of the commands that I sent down and what was the response coming back. And this is called the poor man's bus trace, mainly because then you can actually say, okay, that's great. So you say, Mohammed, that's awesome, but I need to look at the data buffer because there's a problem in the data buffer. So you can go to number 4, and guess what happens? You can actually see the data buffers coming back. Nicely printed out, right? So we have debugged this so many times. You know, we would talk to it and we will say it's a firmware bug, and firmware will be like, no, that's not our bug. And we're like, look, right here, it says it's a firmware bug. And it says, oh, yes, oh, now we get it. And then a lot of other times we have figured out that it's our problem or the device driver's problem or somebody else's problem. So it's a really nice feature, and you can actually, this is also part of the libraries, nothing to do with the utilities. We have just basically, calling into the libraries to saying, hey, give us a bit more verbose mode. So that's what I call a poor man's bus trace. So with that, let's see if I can move on a little bit. We're good on time. All right, so you can basically go on, and it will work on any command. So all of the commands on all of the utilities, you can actually go 1, 2, 3, 4. And it will tell you exactly the command it sent down, what is the sense code coming back from the driver, what is the actual buffer if you're actually a buffered command. So another thing which we like to really love is cherry picking. And cherry picking is you have a bunch of drives, and you need to actually say, hey, I need to update my firmware from this to that. So you can actually use this little thing called only firmware and give it a firmware version. And it will say, so for example, if you know that this firmware version has a bug and I need to go touch it, you can actually put at the very end only firmware, and it will actually work. So let's actually do a demo. And the other one is model match, which really works great when there are people who are very afraid of running our tools on other vendors' drives. So they can either use the only Seagate option, which we will just go figure it out, and we actually go way back. So because we acquired Maxtor and we acquired Samsung's hard drive and we acquired some of the other stuff. So we go back, anything that we have Seagate, we own it. But if it's not Seagate, so you don't have to worry about it. You just say only Seagate. And that's because some of the model numbers are different. So For example, on our NVMe drives, the model numbers start as XF something something, and our ATA drives, it start as ST something something. So when you're using model match, then you're getting like, oh, I want all Seagate drives now. So we just said, okay, we'll make you a nice little thing. But model match is another one where I'd only want to do model stuff on something. So let's try to demo that one. We do Control C. So this all works so let's try something, which is not as, so if we do smart, one of the things it can do is smart check. A lot of people like to do that. I want to make sure that smart check is okay, so I can do dev sg1, right? So it would tell me if my smart check passed or not. So luckily it passed. Now somebody says, I want to do it for all drives that are in the system. So I had like about 20 drives or whatever. So you can do D all, and guess what? It will do one by one, each one of them, hopefully. Live demos are never good. So here it goes. It does all of them, right? So one by one, it did all of them. Now I'm like, oh, but I want to do model MATCH, ST, let's pick one, 6000. So you don't have to actually put down the whole thing. And you say, only do on those. So hopefully they will be a smaller list. Right? So it says, this one smart checked, this one, it didn't match. So it was STI 2000 whatever, right? So in that way, if you have a very mix of different vendors and all these different drives, you can actually use model match, and it will work on any string. It's not tied to, it's just a string. It's doing a model, it reads the model, matches the string, and does something to it. And the firmware version works exactly the same way. So that's a very good way. I like to call it cherry picking. Our customers love it mainly because then they can only talk to the drives that they want to talk to and not to anything else. And that's also part of the...
So it should say skip, check skip, not pass.
Right, so this one it actually just totally skipped. These three and these all, it actually, this drive does not match the input support because this one is a 10 terabyte drive. It did actually work, it tried on this one and it passed because that matched the model string that I sent down. Okay. So that's another, so there are a bunch of different things in that utility that do similar type of things. So firmware and other matches are part of it. So let's see. So it makes life easier for us and our customers and everything else. Okay, another thing that a lot of customer wants to do everything on parallel. And we get that request all the time, that why can't you just put parallel stuff inside your libraries and everything? And we're always arguing that there are many different ways to do this in the OS. So why do you need me to actually do it? And so there's, I have it in here. Maybe I can see if I actually did a little, and you would see all my history here. Maybe I did it, maybe I didn't. Oh, there it looks like, okay. So this one is a utility which openSeaChest logs. So it talks about all the logging and whatever. So it's listing the different logs that are supported, right? So that little thing that I showed you up there is basically taking each one of these drives and running this list supported logs in parallel. So when I do a -d all, it goes sequentially. It picks one drive, does something. It picks one drive, does something. So this little command line will actually do everything in parallel. And it actually works because when I'm going to do it, the output is going to be all over mixed together. So it's actually running everything in parallel. You didn't even see it, but it actually ran on all the different drives and ran it in parallel. So why would it be important? So a lot of times what happens is that we have a customer which is hyperscaler. He wants to collect all the debug logs in the middle of the night, and he gives us 2 minutes. And he has more than 100 drives attached. And he's like, you got 2 minutes to do whatever you want to do, and then you need to be done so that we can do other things. So in parallel, I've actually done it. So one of our logs takes about a minute, 20 seconds to actually pull. And he had more than 150 drives, and we gave him this little script, and they run it, and In 1 minute, whichever drive takes the longest, zoop, all of the logs are there. So in parallel, it's really nice, but it depends on how many processor cores you have. Do you want other I/O to be running and all of other stuff? But what it proves is that our libraries are written in such that we don't disrupt. So if we had written, going back to the original example, if we have gone back and they have actually, every time I talk to a drive, I have to inventory the whole system, that means that this parallel would not work because everybody's going to be collaborating over each other, right? But if my utility only talks to the device or the device handle you ask me to, then this can actually work. And I've used it so many different ways. I just wanted to highlight, if you go here, this is the GitHub/Seagate, by the way. And if you go here, we have pre-built binaries of the non-open version of our tool called SCSI. So SCSI is closed and openSeaChest is, the open version of it, just like SUSE versus openSUSE or whatever. That's what we were going for. And all of the pre-built binaries are here. So let's just take, any one of them. So if you go to firmware, you'll see different versions, and you can go to a version and you'll see different, pre-built binaries out there. But one of the interesting things is that we have these. I actually specifically asked one of my guys to put it out there. And there is a example for Linux. In Windows, there is an example for PowerShell. And then we have examples for Python, to do it in Python, right? And it talks about, so if you open up any one of them, it will talk about, there is for example, in Linux, there is a thing called parallel, which actually does it for you, right? So it gives you different things. So by the way, generic tests is another thing you guys probably want to try out. If I get time, I'll do a demo. It has a bunch of generic tests for drives or stuff like that. So definitely, if you are interested in doing parallel stuff, our libraries work just as good as anything else. I have another little command line, which I didn't put on there. But if you want to actually put everything into a file, because once you run it, you don't know if it ran or not run or whatever. It's a little bit of bash scripting, and you can actually put everything in a file. And then you can actually go grep the file to figure out if it errored out or passed, right? So that's that type of stuff. What's coming down the pipe? So we have an ESXi 6.5 beta version out there. Let me actually show you so that so you guys are like, hey, I have a customer who would like to kind of try it out or whatever. So if you go to Seagate, and then you go to openSeaChest, and then you have we have different branches, and one of them should be, if I can, NVMe, where's my little, am I in the right one? Oh, maybe it's in transport. So if you go to transport and look at that, there's the VMware support. So if you actually, it has already been merged into the develop branch, whatever was stable. But if you want to go to the real tips to make sure you have the latest and greatest, you can actually go to the VMware support. So if you're running VMware ESXi 6.5 and you have SATA, NVMe, or SAS drives, everything that I showed you in Linux would work in VMware.
GPT partitioning?
GPT partitioning as in?
So a utility rather than a different tool in every operating system.
To do actual GPT partitioning? Yeah. I mean, so that's more like a file system layer, Yeah, so I mean, we're more on the device side, right? So it's a physical device versus the other one. Sea Serpent. So as I said, there were 2 or 3 different groups within Seagate that have built Python infrastructures around our OpenSea libraries. And we wanted to open source, so we talked to each one of them, and none of their code was clean enough, and then their management was, kind of hard-pressed to not open source it. So we're calling it Sea Serpent. We're trying to figure out which one to pick. One of them is using the raw way of doing it, like the pack and pack of Python. And the other one was using a scientific library called Nmap or something like that. And we were just, because you're dealing with a lot of buffers going back and forth, and Python is more string-based, right? So there are no built-in Python 2.7 anyway. They don't have built-in data types to actually deal with a lot of byte level, going back and forth. So it's coming down. It will probably be another few months, and then we'll open source it too, and it will be on GitHub, just like anything else. Big Indian support. We have one customer who was using, I want to say PowerPC, and we gave them the source, they built it, and whatever use case that they were trying to do, it worked. And so since we don't own any Big Indian architecture, so we don't know if it works or not, but we are down the road, we want to make sure that our stuff works on Big Indian and it's supported or whatever. But that customer was happy and they're still using it, so I guess it works. I'm pretty sure there are a lot of bugs in it that we need to kind of figure it out. UEFI transport layer, I don't know if any of you are interested in it, but well, we thought it would be kind of cool if I go back to this layer. So in order to actually support UEFI, using the UEFI shell layer, is to just add another transport layer right here, right? So whatever you do is that once you come down to the send IO, you just package it into how UEFI likes to do it, and then you're done. So we have some code. I think there's a branch out there which talks about the UEFI. And so it's coming down the pipe. I would say if there were customers looking for it, we would definitely do it. It's just that most of the customers have moved on from a DOS infrastructure to a Linux infrastructure, so we haven't quite seen the big need to actually support UEFI. But we're nerds, so we're always looking into it, and we thought, oh, UEFI would be kind of cool. JSON, as I said, we already have some other tools which support it, so there's always a struggle between the two, and if any of you guys want to help out and put JSON support in it, happy to do it. RAID. So we do support RAID in our other tools. So one of the differences with this and closed source tools is that we do support RAID, and it works exactly the same way.
Like hardware configuration?
Hardware RAID. So we work on top of LSI's storelib. We work on top of PMC, Adaptac, whatever they're called these days. Their library, and some of the other stuff. We talked to them, we asked them, we begged them, can we put it on open source, or you can do it, and we don't have to touch it, and they didn't want to do it. So we don't own the license, so we can't do it, basically. That's where it stands. Mac is interesting. Everybody and their grandma wants supported on Mac OS X. The problem is Mac only exposes the API for Smart. So you can do a lot of smart stuff to the motherboard attached, anything that is attached to the motherboard, but they don't allow direct I/O. So you can't do a firmware download, you can't do a erase, you can't do anything like that, right? Because they just don't allow it from they have locked it down. But you can do it through USB, but then you have to install a different driver, and it's complicated. So what we do is that we have bootable drives. If you have a Mac, you plug in our bootable drive, you boot to it, you can do pretty much anything that you want. And that bootable drive is the last one link right down here. And you can actually download it. It has all of our tools on it. So all you need to do is go to that link, download that thing, plug it into your Windows machine or whatever, click on I agree to my life or whatever type of stuff, and it will create a bootable USB key. Then you can then boot off of, they have done it on all different types of architecture, right? They just plug it in and it boots up. And it has all the parallel scripts on it. It has all of these utilities and a bunch of other utilities on it as well. So questions, right before that, if you don't go it, if you guys, any of them, you are running Windows or Linux right now, you can go do this. Go to cd make gcc, make release. It's done. That's as simple as building the utilities. If you're running Windows, you do git clone, you go to the make Visual Studio, so we support 2013, 2015, 2017, and in the 2017, you can actually build for ARM for Windows, because that's when they started supporting it. So all of that is out there. You guys are happy to do it. If you guys are building your own on top of it, so you say, hey, Mohammed, we don't want your utility, we're going to build our own, and we want to do a C or C++ one, all you need to do is this file character is your whatever. So in Windows, it will be // physical drive 0, whatever, right? In Linux, it's /dev sg0, sg1, or whatever. And then there's this T device structure that you allocate and send it to us, and we fill it out. And that same T device structure is kind of like the key to any of our APIs. So as long as you get that get device, then you can pretty much call any of our APIs and it works. So I'm giving an example of 3 different commands, which are just generic. So you can create this structure, which is ATA pass-through structure, a generic structure, and call our ATA pass-through command, and we take care of all the rest of the abstraction. Same is with send SCSI command and NVMe command, and these are all part of the same OpenSea transport library. So going back to any questions.
Any plans to do this for enclosures?
So SES, none of our customers actually have asked it, but we have expertise actually. There's a guy in my group who comes from the enclosure side, and he was actually asking me, can I add the support? And I'm like, the minute you're done with your own work, then yeah, you can. But yeah.
Please.
So usually, so most of the stuff that is in there are direct customer requests. So the customer comes in and says, I need a tool for this. And believe me, I've always directed them at the title was very misleading. This all started, one of the OEMs came to us and we were pushing them on ICE, which is the instant secure erase. And they said, how do we even issue the command? And I said, here's an SG raw CDB, you can do it. And they're like, well, we don't know how it's supported or not. And I said, there's another SG raw, and you have to look at the buffer, and these are the bytes. And they're like, that's too complicated. Give us an API. And I said, okay, fine, I'll give it an API. They're like, oh, no, that's still too complicated. Give us this command line tool. I said, okay. So that's how it evolved. So a lot of it, the stuff that is in there, is basically direct requests from OEMs, cloud vendors, whoever. They say, I need a tool for, and we'll do it for them. Go ahead.
So reading a smart attribute is not very hard.
Nope.
But understanding what those 24 bits mean is really hard.
Yes.
Does your library do that?
Actually, there is an analyzed version. So that's a pretty good question. So this one, smart, right? So if you do, and I'll come to the others. I encourage you to actually run this, and where is my smart? Do you guys see it? Smart attributes. So there's a raw, and then there's an analyzed. So you can actually do this -d dev sg1, which is smart attributes raw. So that's your usual SmartMon tool, right?
Yeah.
Okay. So I don't know how if I can smell analyzed ANALYSE. Is that correct? There you go. Yes, sir. I'm sorry? TCG commands? Yes, so that's a very interesting question. So TCG is the enterprise level security protocol. TCG, Opal, Ruby, you guys must be familiar with it. So if you go to our website and you go to that same pre-built binaries, you will actually see TCG support in there. But the open source code does not. And there's I don't want to get it, but I mean, there's some internal discussions on if you want to open source it or not. So if you go to security, and then you go here, and then let's go talk to Linux, and you can actually look at some of the TCG stuff in here. So some of the TCG stuff is in there where you're disabling ports, you're displaying HBA, you're doing SID level stuff, but they didn't, I mean, currently my management is not letting me open source it. Yes, there is. Yes, and there is. I mean, I don't know how portable it is, and so ours is very portable. So again, going back to the reason why we did it was, okay, yeah. You had a question, sir?
Some erase commands can survive the reboot of the host.
Sanitize does, yes.
So can we check
The progress?
status of
Yes, you can. So if I go back to the erase thing, like I tell my internal customers, if you have a "can I do this?" probably it does. So this is the feature called sanitize, which will survive the reboot, right? And there's another one at top up here, which talks about progress. So where is it? Do you guys see a progress in here somewhere? Or maybe
So minus progress.
why can't I see it?
Okay, so we can check the status of
Right, exactly. So you can, oops, sorry. I probably messed up. That's how I like to do it. So yeah, so you can actually, if you're doing a format, you can check on its progress. If you're trying to do a sanitize, you can actually check on its progress and see. And if it is done, it will say there's no sanitize currently running, and last one actually finished. So just one last, because I love this one. So if you do a logs one, can do a bunch of different stuff. By the way, these force flags that you see at the bottom, these are really come in handy if your HBA has bugs. So we found out that there's some HBAs that have bugs. If you send an ATA DMA command, it chokes. You send the same command in PIO mode, it works. So rather than trying to convince them to please fix their HBA firmware, we just added, you can actually put that in your little thing. Just like I did, list supported logs, and this is a list of supported logs in the ATA drive. 7 was the SCSI drive, and this will tell you all of the log pages. Same command, thank you. Same command, and it works in both ways. And there is a generic way to actually pull these logs. So you don't have to do it. So this, where is it? Pull log. You just have to give it the number. So let's try it. D dev SG1. Oops. Pull log, let's say 5 hex dash, is it called log type? Or I don't remember what it was. Let's see what it does if I just do it that way. There you go. Oh, it says 5 is not supported. 7, there you go. So it does the raw, and I think you can actually say, I want it in a binary format, I want it in whatever format, so you can actually just pull logs and display it right there and do a lot of stuff with it. All open source, by the way. Works on all vendors. Any other questions? I think we're ready.
You should really give this guy some time to add the stuff.
Okay.
3 requests.
3 requests for SES. All you guys need to do is you have a...
Asking for tape, right?
Yeah. If you guys have a Seagate account people that you talk to, or any kind of a salesperson you had talked to, because I mean, that will be the best way, because then it trickles down from my management, right, other than me telling. But I'll definitely give that feedback. So.
Did you get any requests to support
AIX?
AIX?
AIX. Oh, the architecture AIX?
No, it's IBM operating system.
Yes. So somebody actually took it and they never came back, which is usually a sign that it worked. Yeah. So they might have to do some tweaking to it, because a lot of times that's how customers are. When it works, they don't come back. When it doesn't work, then when they scream. So, but I don't have any test cases or things like that for it. Right. All right. Thank you, guys. Appreciate it.